huge, greater than the immense Jupiter, with a measurement of right around 140,000 kilometers. The ruler of our planetary framework is enormous to the point that Earth would hypothetically squeeze into it more than 1,000 times. At the same time, the huge gas giant is around 2.5 times more massive than all other planets in the planetary group combined. But did you know that this planetary mammoth is a true speed demon? In fact, Jupiter only needs a little less than 10 hours to rotate on its axis, making it the fastest spinning planet in our solar system. Aside from its spellbinding magnificence, Jupiter is also the scene of massive storms and intense radiation. What secrets lie hidden beneath its thick bands of clouds? What do we know about the Great Red Spot, which is larger than Earth and whips across the planet's outer layers at an insane speed of up to 680 kilometers per hour? And most of all, would our own planet ever have appeared if Jupiter hadn't rampaged through the solar system in its early days like a cosmic berserker? A few years ago, researchers at the University of Bern were the first to successfully determine the true age of this imposing gas giant. Since the celestial body has no solid surface and thus cannot provide rock samples, the researchers took a different approach to determine its age, making deductions from meteorites. The key discovery, however, was that Jupiter had grown to 20 Earth masses in less than 1,000,000 years after the formation of the solar system, completing its development after another 3,000,000 years. By comparison, Earth, with a mass more than 300 times smaller than that of Jupiter, took a whopping 100 million years to reach its planetary completion. Not only is the massive celestial body the largest, but it is also the oldest planet in our solar system. Formed from the dust and gases left over from the Sun's creation 4.6 billion years ago, Jupiter's composition reflects this origin. Like the Sun, the gas giant is primarily made of hydrogen and helium, which explains its relatively low mean density of 1,330 kilograms per cubic meter. Yet, despite being cut from the same material, Jupiter and the Sun are now separated by an average distance of 778 million kilometers. The double XXL planet orbits beyond the asteroid belt, between the paths of Mars and Saturn, taking just under 12 years to complete one orbit around our central star. However, strictly speaking, Jupiter doesn't actually orbit the Sun. To understand why, we need to discuss the concept of the barycenter. The barycenter describes the center of mass that planets and stars orbit together. This is usually closest to the object with the greatest mass. Because the Sun's mass is over 1,000 times greater than Earth's, the barycenter for these two bodies is close to the center of our star. However, since Jupiter is significantly heavier than Earth, the center of gravity for Jupiter and the Sun is actually just outside the surface of the Sun. The more massive an object, the stronger its gravitational pull on other bodies. Since Jupiter has an impressive mass of around 318 Earth masses, its gravitational force shapes the structure of the solar system in many ways, including in close proximity to Earth. We now know of 95 moons bound to Jupiter's gravitational field. Notably, the subglacial ocean on Jupiter's moon Europa is even thought to potentially harbor extraterrestrial life. Further studies are needed to determine how much truth this remarkable hypothesis holds. So far, the gas giant has been the target of multiple research missions and flybys. Currently, NASA's Juno probe is devoted to exploring the Jupiter system in detail. And more research is on the way. The ESA probe JUICE, Jupiter Icy Moons Explorer, set off for Jupiter on April 14, 2023, with a planned arrival at the gas giant in July 2031. Jupiter's gravity is more than 2.5 times stronger than Earth's, acting as a natural protective shield. Due to its formidable mass, its strong gravitational field diverts comets and asteroids that might otherwise hit Earth. However, the proximity to such large planets isn't always beneficial. One study concluded that these massive planets sometimes eject smaller planets from habitable zones. Jupiter itself has a history as a cosmic wrecking ball. It is believed to have originally formed 5 times farther from the Sun than its current orbit suggests. In fact, Jupiter may have temporarily migrated into the inner solar system, causing chaos but also enabling the formation of Earth. Simulations indicate that Jupiter's gravitational pull carried large amounts of debris and planetary building blocks with it, seeding the early solar system with materials necessary for the formation of terrestrial planets like Earth. This cosmic migration cleared out much of the early solar system's interior, paving the way for the second wave of formation for small, rocky planets, including Earth. This scenario could explain why our solar system is so different from others, where most inner planets are large gas giants or super-Earths orbiting closely and rapidly around their stars. Now, turning to Jupiter's optical appearance, we notice its distinctive bands, which may seem like a stylish striped pattern at first glance. These almost parallel bands are clouds visible even through small telescopes. The bands range in color from white to blue, with the lighter zones cooler and denser than their darker counterparts. These lighter zones contain rising gases, likely giving them their color due to ammonia ice. The darker belts, on the other hand, may owe their hue to elements like phosphorus, sulfur, and possibly even hydrocarbons. Interestingly, these prominent bands change color every 4 to 5 years, which could be linked to cyclic oscillations in Jupiter's magnetic dynamo. The Great Red Spot, Jupiter's largest storm, rotates at speeds up to 680 kilometers per hour. This massive anticyclone is currently about 1.5 times the width of Earth and has been raging on Jupiter since at least 1830. In comparison, storms on Earth usually dissipate within a few weeks. Despite its long history, the Great Red Spot has shrunk significantly. In the 1880s, it was estimated to be 40,000 kilometers in length, but now it measures only 16,500 kilometers. NASA suggests this is due to interactions with smaller storms. The storm also experiences fluctuations in its shape and movement, changing its appearance multiple times over a 90-day cycle as it shifts from east to west and back again. These oscillations correspond with seasonal fluctuations in the size and brightness of the storm's eye, which tend to increase when the storm is moving slowly. The Great Red Spot often appears to shudder, almost as if it were trembling. Why this occurs is not yet understood, although interactions with the fierce winds surrounding the storm are likely to blame. So, what does the future hold for this monumental structure? Given its historical reductions in size, scientists are now investigating if there is a lower size limit, beyond which such a persistent storm might become unstable.